Guys, section 4.2 is all about prime factorization and simplifying fractions. So the first thing we're going to do in objective A is writing the number as a product of primes, but before we do that we need to know what a prime is, all right? So a prime number is a natural number greater than 1 whose only factors are 1 in itself, okay? So you can't split it up any other way other than 3 and 1, 5 and 1, or whatever. 2 is the only even prime number, because any other even number, 2 would go into it, all right? So this is a list of the first handful of prime numbers, 2, 3, 5, 7, and so forth. A composite number, what's it mean to be composite? You're made up of multiple things. And so a composite number is made up of multiple factors. So if you can break it down to more than 1 in itself, it's a composite number. So any even number is a composite number because 2 can go into it. And then, of course, some odd numbers like 9, 27, 15, and so forth. So how do we do prime factorization? I go old school. It's kind of the no-fail method. You do factor trees, okay? And I want you to realize with factor trees that you might do it different than your neighbor, but ultimately you should all get to the same answer, all right? So how do you do factor trees? You make the branches scored off, and you come up with any two numbers that multiply to be 30. 10 and 3, 5 and 6, 2 and 15, it doesn't matter. So I heard 10 and 3, so I'm going to do 10 and 3. Then what you do is you go to each of those ends of the branches and break them up, okay? So how can 10 split up? 5 and 2. And how can 3 split up? He can't. He's prime. So once you've broken all of your branches down to primes, the ends of the branches are your prime factorization. So 5, 2, and 3. Don't throw 10 in there, right? Because what did we break 10 down to? 5 and 2. So how do you show your answer as a product of primes? You literally just multiply them, okay? So it's just 2 times 3 times 5, like that. And if you multiply those guys all in a row, you should get your original number. 2 times 3 is 6. 6 times 5 is 30. You did it correctly. Guys, if you did it 3 and 10. If you did it 5 and 6, the 5 wouldn't break down anymore, but the 6 would break down to 2 and 3. You would still get the same factors, 2, 3, and 5. So I want you to know, as long as you pick 2 correct factors, it doesn't matter which ones you pick first, all right? 56, what are any 2 numbers that multiply to be 56? 8 and 7. Let's start with 8. What does 8 break down to? 2 and 4. Can we break 2 down any further? No, but what about 4? 2 and 2. So this side has been broken down as much as possible. Let's go up to this other branch, 7. Can 7 be broken down any? He's a prime. So what I'm going to show you is 2 different ways how you can write your answer. You can write this as 2 times 2 times 2 times 7, right? We have the 3 2's on the left side and that 1 7 on the right. Or, what's a more concise way you can write this? 2 to the third times 7. Perfect. Either or, okay? Typically, it's just whatever's easiest for you. Writing 2 to the third times 7 is quicker, but maybe on my math lab, doing exponents is a little harder, so it's easier just to do 2 times, I don't know. You choose which way you like. Again, notice we didn't include 8 and 4, because both 8 and 4 broke down further, okay? It's just only the ends of your branches. 72, what are any 2 numbers that multiply to be 72? 12 and 6, 8 and 9, 3 and 24, 2 and 36. There's multiple ways to do it, okay? So let's do 12 and 6 because I heard that one first. All right? And then just start with your left branch. What does 12 break down as? 2 and 6. And then how does 6 break down? 2 and 3. Perfect. Okay? So we're just coming up with any 2 numbers that multiply to be those numbers. With 12, you could have broken it down to 3 and 4. Either way, with 12, you get 2 2's and 1 3. All right, go back up to 6. He can break down to 2 and 3. So let's write it as the concise way, all right? Let's look at the ends. We have 1, 2, 3 2's, so we're going to have 2 to the third times 2, 3, 3 to the second. Does that look right? Does everybody see where those numbers came from? Again, don't include 12 or 6 because they broke down a little bit further to those 2's and 3's. All right, so example 2 doesn't force you to do a factor tree. So notice on 1 they say use a factor tree. Number 2 just says write the prime factorization, but guess what I'm going to do? a factor tree. Like, I mean, that's how I do it. So what are any two numbers that multiply to be 60? 2 and 30. 2 is already a prime, so I'm leaving him alone. And what are any two numbers that multiply to be 30? 3 and 10. 3 is already a prime, so I'm leaving it alone. What are anything that multiply to be 10? 2 and 5. All right. All of our branches are dead ends at this point, okay? So we're going to gather them. So we have 2 to the second times 3 times 5. Does everybody agree with that? We have 2, 2, so it's 2 to the second. We have 1, 3, and then we have 1, 5. So that's our final answer. Are there any questions there? The second half of this page, guys, I wouldn't worry too much about. It's just that when you get into these bigger numbers, it's hard to know what goes into those bigger numbers. And so these are some divisibility rules. If you're even number, you know it's divisible by 2. If you sum the digits of a number and that is divisible by 3, the number is divisible by 3. That's the same rule with a 9. If you sum the digits and it's divisible by 9, you know the number is divisible by 9. It's kind of cool. If the last two digits are divisible by 4, then the number is divisible by 4, blah, blah, blah. You don't need these memorized, but maybe you could flip to them here and there while you're working on your worksheet or on your homework just to help you get started with some big numbers, like where do I start? So go ahead and flip it to the top of the second page. 297. It's a big number. I don't even know what goes into 297, but it's odd, so I know 2 doesn't go into it. So what I'm going to do is I'm going to try the divisibility by 3 rule. That means if you add these 3 numbers and that number is divisible by 3, this whole number is divisible by 3. So 2 plus 9 is 11, plus 7 is 18. 18 is divisible by 3. So guess what this number is divisible by? 3. So it's 3 and something. I don't know what. So go over here and do 297 divided by 3. 3 can't go into 2, but we can, how many times does it go into 29? Not perfectly. 9 times, because 3 times 9 gets us to what? 27. Do the subtraction, you have a 2, and you bring down the 7. How many times does 3 go into 27?
99.
9 times, perfectly, right? So, if you get a remainder of 0, that means that is a factor, okay? If you get a remainder of anything other than a 0, that means it does not go in, it's not a factor. Try a different number. Try 7, or try 5, or 9, or something, okay? So, what's the other factor of 297? 99. I like 99 because it's a multiple, 9, 9. What number always goes into them when the numbers repeat? 11, right? So, this splits up as what? 11 and 9. 11's a prime number, but what does 9 split up as?
3.
3 and 3. So when it's all said and done, this really large number of 297 is 3 to the third times 11. It's pretty impressive that you guys are able, I mean, I know you don't think this way, but like you guys are doing all this without a calculator. Like you just divided 297 into primes. Like who does that? Like, I don't want to. I'm forced to. I don't want to, though. All right, so why do we care about this? Because this is actually how I teach simplifying fractions. So with a fraction, you have a numerator and denominator. And how I teach it is break down the top like we were doing, break down the bottom like we're doing, and anytime you see a number over itself, it reduces to 1. And that's all this is showing you. 5 over 5 is 1. 24 over 24 is 1. Any number over itself is 1. So if we have a factor on top that matches a factor on the bottom, we can cancel them out as 1, all right? So what I do is I do it a little bit longer methodical, but if you can do it real quick, that's fine. But I'll show you my way, okay? My way says take your numerator and do a factor tree for it. Let's figure out the prime factorization. Well, we've done 30 a couple times already. I think we always shout out 3 and 10. And then that breaks down to 2 and 5, right? So over here, up here by our fraction, make a big fraction bar. We can rewrite 30 as a 2, a 3, and a 5. Do you guys agree that's 30? Because 2 times 3 is 6. 6 times 5 is 30. Then do the exact same thing with 45. What are any two numbers that go into 45?
5 and 9.
5 and 9. Yep. So we'll do 5 and 9. 5's a prime, so we're not going to break him down any. But 9 splits up to 3 and 3. So what can we put on the bottom? We can put 2 3s and a 5. And notice I'm not using the power rule here. I think if you use the power rule, it's hard to know what cancels, so I always keep it all spread out. At this point, if you see a factor on top that matches a factor on the bottom, that's technically 1. And they do not have to be exactly over each other because we can rearrange stuff as much as possible, okay? So as long as you see it on top anywhere and on the bottom anywhere, it will cancel. What do I mean? Does 2 have any 2's to cancel out down here? No, but what do you notice this? 3 over 3, that's just 1, so we can cancel that out. And what about the 5 and the 5? Cancels out. So what remains, you multiply straight across. What's the only thing that remains up top? 2. What's the only thing that remains on the bottom? 3. So you guys simplified 30 over 45 to a fraction of 2/3. Okay? I do it this way because some of you might look at 30 and 45 and think, oh, 5 goes into both of them. And you reduce it to 6 over 9 and you stop. Well, if you don't get the biggest factor right off the bat, you're not completely simplified because 6 over 9, they still have a factor of 3 that could go further. So mine, like, this is kind of like the no-fail method. You have to do a little bit more work because you're breaking them all completely down, but you'll always find all the factors. If some of you can look at 30 and 45 and know that 15 goes into both, great, good for you, do that. But sometimes you start missing things, all right? So we're going to do the same thing down here. 39 is kind of weird, but it's odd. So what we're going to try is 3. Well, how many times does 3 go into 39? I don't know. Throw it over here. Yeah, it is 13 times, okay? 3 goes into 3 once. Bring down the 9. 3 goes into 9 3 times. So 3 and 13. Both of them are prime numbers, so we're done with the top. So I'm going to go back up here, and we'll write 3 times 13 times x. The x is just tagging along, all right? 51. I don't know. If it's an odd number, guys, I always start with 3, okay? So over here, I'll do 3 into 51. 3 goes into 5 once. Do the subtraction. 5 minus 3 is 2. Bring down the 1. 3 goes into 21 how many times? 7. So what are my two factors of 51? 3 and 17. Both of which are prime. So I'm just going to go back up here, and instead of writing 51, I'm writing the two factors, 3 and 17. At that point, you guys, after we've done it, what's the only thing that reduces? The 3's. Did you have a question?
Why did you choose the 3?
Because if it's, what I do is if it's a number I'm not familiar with, if it's even, the first thing I always try is a 2. If it's odd, the first thing I always try is a 3. I got lucky both, yeah, I got lucky both times, but if 3 didn't work, I'd try a 7 next, okay? So I'm just trying odd numbers to go into odd numbers, okay? Or I could have done the rule, 5 plus 1 is 6, 6 is divisible by 3, so I know 3 goes into it. That's where those divisibility rules on the bottom of the front page might come in handy. Okay, so up here, guys, only the 3's cancel. So how are you going to put your final answer? 13 times x is just 13x, and then 17 is just 17. So you have 13x over 17. Is that all right? All right, go ahead and flip it to the top of page 3. They're going to try to scare you with negatives, but guess what? Your answer is still negative. So like right now in my math lab, I would just type a negative into my answer box so I wouldn't have to worry about the sign at all, okay? So I'm just going to write negative something, all right? 9, you don't really need to do a factor tree for 9, but if you want to, you can. How does 9 split up? 3 and 3. And then 50, I'm going to do a factor tree over here. What are any two numbers that multiply to be 50? 5 and 10, perfect. 5 is a dead end, but 10 splits up to 5 and 2. So over here, I'm going to write 1, 2, and 2 5s. What do you notice when we do that? Nothing reduces. That's okay. So sometimes you do this and you're like, God, why did I do all that work and it didn't reduce? Because the second you don't, it reduces, okay? So if you can look at it and realize 9 and 50 don't have any common factors and you don't need to reduce it, that's fine. But I always kind of just cover my butt and I factor, and if they don't have anything, that's fine, okay? So your final answer is going to be negative. 3 times 3 is 9. And then 2 times 5 was 10 times 5 is 50. It's just your original. It didn't reduce. We didn't cancel out anything. So what's our final answer? The original guy, right? So people are like, well, how did you do that math so quick? Because That's how we broke it down. We broke 50 down into the 2 and the 2 5s. 49 over 12, look at these crazy numbers, okay? So 49, do we need to do a factor tree for 49, or are you guys okay there? What's 49 split up as? 7 and 7. So I'm not going to worry about a factor tree there. But 112 I am, and this kind of answers Ellen's question. I don't know factors of 112, but I know it's an even number. So guess what I'm going to do over here? 112 divided by 2. Okay, I'm going to get my other factor. So 2 doesn't go into 11 completely, but it goes in there 5 times, because 2 times 5 is 10. Do your subtraction. 11 minus 10 is 1. Bring down the 2. So 2 goes into 12 6 times perfectly. All right? So what's our other factor? 56. So we have 2 and 56. And then by doing that, you usually get it down to a number that you recognize. So like when we did it again, we got it down to 99, so we knew to, divide by 11. 56, what are any two numbers that multiply to be 56? 8 and 7. And then 8 is what? 2 and 4, and then 4, 2 and 2. So 8 breaks down a lot, guys. At this point, we're just going to look at the ends. 2, 2, 2, 2, and 7. So 112 is 4 2s and a 7. All right? We do all of that to realize only 1 7 cancels, but that's okay. At least we would catch everything else that potentially would cancel. So pick any 7 on top to cancel out with either that 1 7 on the bottom. So what remains up top is a 7. What remains on the bottom is 2 times 2, which is 4, times 2 is 8, times 2 is 16. Make sure you keep multiplying by 2. You don't just say, okay, I have 4 2s. 4 times 2 is 8, right? You say 2 times 2 is 4, times 2 is 8, times 2 is 16. Or you can pair them up, right? 2 times 2 is 4. And what's 4 times 4? 16. Either way, guys, make sure you get 16 down there.
Why is it you crossed out the 7?
Because there's 2 of them one on top and one on bottom.
So what we're trying to do is we're trying to find one number over itself. Because what's 7 over 7 reduced to? 1. And so your whole goal, Ellen, is to look at your top and say, can I cancel out with anything on the bottom? They don't need to be right over each other or anything. So you just look.
Same number.
Just the same number, yep. So this 7 cancels out with that 7, and that's the only thing. If there were 2s up top, we would start canceling the 2s with the 2s on the bottom. But the reason why we can cancel them is because we're canceling out a 1, right? Because 7 over 7 is 1. Mm-hmm. Yes, yes. So remember, oh yeah, you can do 4 and whatever. You can do, there's multiple ways. You could have done 8 and something. You could have done 16 and something. That's what I'm talking about. Whatever kind of comes your way first, go that direction. Especially with the bigger numbers. The bigger numbers, the more ways to break them down. All right. This next one, guys, is negative. So I'm just going to type negative into my MyMathLab box or put a negative in front of my fraction. 64 is a perfect square. What does that mean? It means it breaks to two things evenly. What? 8 and 8. But then each of the 8s break down to 2 and 4, and each of the 4s break down to 2 and 2. So guys, when it's all said and done, you have all these 2s. Okay, that's all you have. So 64 ends up being 1, 2, 3, 4, 5. I'm writing the number 5 and not that. Sorry. You get 6 2s for 64. It's 2 to the 6th power. And then 20, you may or may not have to do a factor tree. But what are any two numbers that multiply to be 20? 2 and 10. But why does that help us? Because 10 breaks down to 2 and 5. Okay? So 20 ends up being a 2 times a 2 times a 5. So we're going to be able to cancel out one set of 2s. So this 2 on top cancels out with this 2 on the bottom, because that's a factor of 1. This 2 cancels out with this 2. That's it, right? So yeah, so we're going to multiply straight across. Remember, our answer is negative. And then we just did 4 2s right above, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. What's the only thing on the bottom? 5. When we cross out things, guys, we're crossing out factors. So what did we cross out? A 2 and a 2. So we actually reduced each by 4. So if you can see that that goes by 4, you can do that. Yes, sir. Did you have a question?
Yeah, 4 because 2 times 2 at the bottom equals 4. Like, I would get this into at the bottom.
Right here? Yes, that's what I'm saying. Like, if you can see the bigger factors, that's fine. Like, you're like, okay, I know that has a 4 in it and that has a 4 in it, and you can kind of go right to it. There's another one where I can show that too. Okay. This next one, guys, again, variables scare us, but variables are easier than numbers because you don't even have to think about how they break up. You just know that you have 3 A's or 3 B's. That's all you have to do. So on the top, there's no factor tree. That's just going to be 7 times A times A times A. Right? A to the third is just 3 A's. There's no thought process there. We don't have to think, okay, what 2 things multiply to be A? 56, I am going to do that. What 2 things multiply to be 56? Guys, we just did it up here, 8 and 7. So use things that we've already done. 8 splits up to 2 and 4, and the 4 splits up to 2 and 2. So again, we're looking at the ends of the branches. So we have 3 2's and a 7. And then how are we going to show A squared? A and A. Do you guys see everything there? So that 7 doesn't break up, so he stays a 7. And then A cubed is 8 times 8 times A. 56 was 8 times 7, but we've seen this a couple times. 8 ends up breaking down to 3 2. So here's my 8 times my 7, and then A squared is 8 times A. And so then you just start with the top. You say, can that 7 on top cancel out with anything on the bottom? It can. There's a factor of 7 down there. So there's a factor of 1 that I just knocked out. What about the A? Yep. What about this A? Yep. But he doesn't have anybody else, okay? So what's the only thing that remains up top? The A. And then what remains on the bottom? The 2 times 2, which is 4, times 2 is 8. A over 8 is what that reduces to. But do you guys see how it's the exact same thing with the letters? We don't know what A is, but if it's A over A, if A was 2, that's 2 over 2. If A was 5, that would be 5 over 5. Even though we don't know what A is, it over itself is always just 1. So you can cancel them out. All right, you guys are doing awesome. This last chunk's always kind of hard for me. I never really know how to teach it. Basically, it's determining whether 2 fractions are equivalent or not. And sometimes it's really easy to see and you can just jump right to it. And sometimes it's a little bit hard. So this first one, I noticed that, hey, 9, if I multiply 9 by something, I can get to 27. Like they have that common factor, right? What do I multiply 9 by to get to 27? 3. So the question is, if I multiply the top by 3, do I get 21? Yeah. So 7/9 times 3 over 3 is just 21 over 27. They are equivalent fractions, right? This just breaks down to him. And again, like I said, I never even really know how to teach it. It's kind of awkward. But basically, 21 over 27, guys, would reduce down to 7/9. So when they ask, are they equivalent, we would say, yes, they are. All right, the next ones, they're not that easy. And I can't look at them and know. 13 and 8 have no common factors. So what I'm going to do, and again, we don't really know this yet, so that's why I don't like teaching this, is I'm going to make 13 turn into a denominator that times by multiplying by 8 over 8. Kind of like just finding that common factor, okay? So up top, what's 4 times 8? And all I did was pick the other guy's denominator. That's where that's coming from. I'll show you in a second, okay? So this is 32. And then I don't know what 13 times 8 is, so I'm going to do that over here. 8 times 13, or 3 is 24, carry my 2, so that's 104. So basically what I did was I took 4/13 and I multiplied by the other denominator, or a factor of 1, to get it down to 104s. I'm going to do the exact same thing with him. 5 over 8, and I want to get it to 104 again. Well, I'm just going to multiply by the other denominator. I already know 8 times 13 is 104, but if I multiply the bottom by 13, I need to multiply the top by 13 because I'm just multiplying by a factor of 1, okay? So I know it's kind of weird, but what we're doing is we're not changing the fractions at all. We're just getting them so we can compare them. Like, remember my cookie cake slices? I don't know how to compare a cookie cake that's in 13 pieces or 8 pieces, but if I cut this to 104 pieces and I cut this to 104 pieces, they're all the same size, so I can compare them, all right? So what's 5 times 13? 65, okay? What does that mean? It means 5/8 cut into 104 slices is equivalent to 65 slices remaining, but 13 cut into 104 slices is equivalent to 32 slices remaining. Is that the same? No. Sheridan, you want me to go over that again? When they don't have a common factor, so I think example 10 was easy because it was obvious that we just multiplied by 3. We multiplied by 3 on the bottom, 3 up top. When they don't have a common factor like 13 and 8, there's nothing that they share, I make the denominator the product of the two, okay? So I'm just taking 13 times 8, 8 times 13, so I can get them in the same amount of slices. Yay, nay? Okay? But the reason why I did the opposite denominator over the opposite denominator is because really I'm just multiplying by 1. I'm not changing them. I'm just taking 13 slices and then cutting those 13 slices into 8 more slices to get 104 slices. Like I said, it's kind of awkward. If you don't get it 100% right now, I'm okay with that because we're going to kind of discuss it on Thursday when we start adding and subtracting fractions. I feel like this is introduced too soon. Like, again, I'm not an author of a book, so I shouldn't be ripping on it, but I think this is something that is, unless it's obvious like this gets really weird, okay? But this would be no, because this, or you can even look, guys, you can kind of eyeball it. I know this is kind of weird. 5/8 is more than a half. 4/13 is less than a half. If one's more than a half, one's less than a half, they're not the same, okay? I don't like it, but don't worry too much about it if you don't get it, okay? Last thing, guys, we did this exact same problem, but we never had to simplify before. So remember when it comes to writing a fraction, your total's always the bottom number, and how many you care about is the top. So it says there are 58 national parks in the U.S. 8 of them are in Alaska. Determine what fraction of the United States national parks are located in Alaska. Write that as the simplest form. So on Thursday, you guys did a worksheet where you had to write it as a fraction. What's our denominator going to be? It's the total amount of parks. So how many total parks are there? 58. How many are in Alaska? 8. And that's all you had to do on Thursday. We're like, here's a fraction that represents the total parks in Alaska. Now we're going to reduce it. Well, we're just going to do like what we did before. We already know what 8 splits up to. We've done it 100 times. It's 3 2s, remember? If you don't remember, come over here and do a factor tree. 2 and 4 multiply to be 8. 4 splits up to 2 and 2. So 8 is 3 2s. 58, kind of a weird number, but it's even, right? So what number am I going to try? 2. So I'm going to do 58 divided by 2 and see how many times 2 goes into 58. 2 goes into 5 how many times? 2 times. What's 2 times 2? 4. Do your subtraction. 5 minus 4 is 1. Bring down your 8. You get 18. 2 goes into 18 how many times? 9 times. Evenly, right? So what does that mean? What's his other factor? 29. But if you flip it over to the front page, guess who's a prime number? 29. So we're done at 2 times 29. So we just put 2 times 29 up here. So again, try to use all those. It's kind of like I was telling you before, you don't have to jump to the right answer right off the bat. Try 2 if it's even. If it doesn't work, try something else, okay? At that point, who can cancel out? 1, 2. So who remains? 4 over 29. So it gives you a better idea that 8 out of 58 parks are in Alaska, or 4/29 of the parks are in Alaska.